Alright, this is for those of you that haven't been able to be here when we did set up for the honors precipitation and reaction and formations of solid. We teach you how to do it. You need to do this prediction part before you come to class on Tuesday, because we're going to be doing it on Tuesday for those that are in B Day. For those that are on A Day, we're doing this lab on Thursday the previous week. So if you missed it, you need to do this first and then come in before Thursday or Tuesday next week when I'm taking it down. Alright, so the pre-lab. You need to balance and complete and balance following reactions. What I like to do is I like to take and write the ion right above the name. So sodium is Na, so I write Na, and it has a +1 charge. So I write +1. Carbonate, if you look on the back of your periodic table, is CO3, and it has a -2 charge. Silver is Ag, and it tells us here that it's a +1 charge. Nitrate, again, is on the back of your periodic table, so you would write NO3 with a -1 charge. Okay, now what you're going to do is you're going to put these together. So if I look at the sodium and the carbonate, they have to add to equal 0. So I've got a +1 and a -2. So I'm going to need two +1s to add to the -2 to equal 0. So I write Na subscript 2 CO3. Add to that the other compound, which is made of silver and nitrate, +1, -1, already balanced. So I just write Ag and O3. Now both of these are solutions, so we put down here at the bottom AQ. AQ. Now what we're going to do is we're going to do OI, outside inside. So we're going to take the outsides and put them together, and the insides, because it is a double displacement reaction. So, outsides. Now sodium and nitrate, +1, -1, smash it together. Na NO3. And we don't know if it's aqueous or not. We're going to have to look that up on our solubility rules. So we put a plus. And when we do the inside, always remember to write your positive first. That's the thing most kids mess up here. When you do oil, you always write your positives first. So Ag is going to go first, and it's got a +1. And CO3 has a -2. So I'm going to need two silvers to go with one carbonate to make that equal 0. Now this is when you look at your solubility rules that you got in class. If you didn't learn in class, you need to come get them. Also look at them up on YouTube or wherever, but I've got a paper for you. And you'll need to do that Sweet 16 if you didn't, and check it out with me. Okay, so we look on the back and we find out alkali metals, which sodium is one of, that's the first column in the periodic table, are soluble. So are nitrates. So sodium nitrate is very soluble. So we put an AQ here. Then we also look on the back, and we can't really find any things that talk about silver, but a lot of them have silver in them. But we can find carbonate, and that's down towards the bottom. And it says most carbonates are insoluble, except with alkali metals. Well, this is not an alkali metal. Silver is insoluble. So we put an S, meaning it will make a solid. Okay, it'll make a solid. Now, the second thing that we worry about up here, so I'm going to erase this up here so we see it, is to identify the precipitator solids using the solubility rules. That's what we did up here on the left-hand side. So the precipitate is the one that makes the solid. So that is Ag2CO3 is going to be our solid. Then the next thing we want to do is we want to write the net ionic equation for each reaction. So, net ionic equation means I'm going to make my solid. So I'm going to make Ag2CO3. I'm going to make it out of its ions. So I work backwards. How many ions of silver made this up? Oh, well, I needed 2. So I put 2 Ag, and Ag had a +1, and as an ion, it has to be aqueous. Plus, well, what's left? CO3, and only one of them, so I put CO3. It had a 2- charge, and it will also be aqueous. And that's all we have to do for each one. Now, some of them you will have more than one thing, you might have more than one thing that's solid. Some of them, you might have what they call slightly soluble. Now you're trying to predict if you will see this or not. I did spell that wrong, sorry. Soluble, there we go. Slightly soluble. So what you want to do is if you end up with a slightly soluble, make yourself a key, maybe make it out a star, and put a star next to it in your equation, and then you go down, so that when you finish, that was not slightly soluble, so I moved it. If you don't see it, you know why. But if you do see it, you know why. There's also going to be what they call moderately soluble. And you want to do a key for that, maybe a triangle or a square or a circle or something. Okay, I probably wouldn't use a circle because you might think it's oxygen. But find some kind of symbol that you can use to indicate it's moderately soluble so you have that same issue. Now these number 2's, you're going to take and put on the back sheet where you have a grid where you're going to predict if you're going to see it. If you're going to see something, if you have something in number 2, you're going to put it on that grid. So where sodium carbonate and silver nitrate connect in that grid, you're going to put silver 2 carbonate, silver subscript 2 CO3. And if there's nothing there, you're going to put an X. Okay? So that's what you need to do before you do this lab. This lab only takes about 5 minutes, so if you missed it in class, you can quickly come and do it real fast during the tutorial or during before after school. Okay, thanks. We'll see you in the class.